Hello class, this is the third example on applying mathematical induction to divisibility tests. This one is slightly more lengthy, so I've already pre-written some of the work. At any time you can pause the video and give this a go yourself, and just be mindful that your work might look slightly different to mine, but it should generally follow the same direction. So here we go. We begin the statement by saying that if the statement is divisible by 3, then the same expression must equal 3m for any integer m is greater than or equal to 0. As before, we always test the smallest value in the given domain. So n is equal to 0, 0 cubed plus 2 times 0 is equal to 3m. We get 0 cubed is 0, plus 2 times 0 is also 0. 0 is equal to 3m. So this is true for n is equal to 0, since m can equal 0 in this instance. So for any integer k is greater than or equal to 0, we assume true for n is equal to k. So now our expression, instead of n, is going to be k. So k cubed plus 2k plus 2k is equal to 3m. From here, we're going to prove true, or prove, for n is equal to k plus 1. So now our expression is going to be k plus 1 cubed plus 2 times k plus 1 is equal to 3m. So now focusing in on the left-hand side. Here's where it gets a little bit tricky and lengthy. If you tried expanding k plus 1, you're actually going in the wrong direction. A few things that you should take a look at is, if you notice that you could factorize it, it might be the case that you actually should factorize, which is what we're going to do. So we get k plus 1 outside of k plus 1 squared plus 2. This remains the same. Expanding this group, we get k squared plus 2k plus 1 plus 2. Collecting like terms, we get k squared plus 2k plus 3. Now at this point, sometimes you might think, oh, I'll simplify it even further by factorizing. But if you try and factorize this, you'll see that there are no numbers that multiply to 3 and add to 2. So if you try and factorize this in any way, you'll come to a dead end. Now, it's not always advised, but it's not a never rule. So it's not advised that we expand, but in this case, this cannot factor. So we expand it. So now take a look at how I expand this. K times k squared, k cubed, k times 2k, 2k squared, k times 3, 3k. Now here's a little neat trick I found when it comes to expanding multiple terms in a group. 1 times k squared is plus k squared. 1 times 2k is 2k. 1 times 3 plus 3. Now since everything's lined up, we just simply add vertically. K times nothing, sorry, k cubed plus nothing, k cubed. Adding the next term is 3k squared plus 5k plus 3. Now at this point, if you try and factor or do anything like that, you'll once again reach a dead end. But I'm noticing here that 3 and 3, if this were a 3, we could factor out all the 3's, in which case it would be divisible. And this needs to be a 3k cubed somehow as well. Or, well, a 3 something. Well, if you look back, and it's usually the case when you hit a dead end like this, look back at our initial expression. We have k cubed, so if we make that the subject, maybe if we substitute, we can progress further. So let's take a look at what happens if we try that. We get k cubed equals 3m minus 2k. So substituting that into our expression here. Oops. So that is substituted plus 3k squared plus 5k plus 3. Collecting like terms, this is going to be 3m. These two are like terms, so those will add later, but this is going to be plus 3k squared. The like terms of the k values plus 3k plus 3. Now, since all of them have a factor of 3, so I'm going to copy this out and let's move up back to the top of the page. They all have a factor of 3. We can factor that out to give us 3 outside of m plus k squared plus k plus 3. Now remember, k and m are just some sort of integer. So once again, you can say that this is of the form 3m. So that expression looks something like 3m, which is equal to the right hand side. So third statement, or the third step, I'm just actually gonna take this to make it a little bit easy for us, to save us some more time. From step 1 and step 2, the expression, instead of that, the expression n cubed plus 2n is divisible by, not 4, by 3 for any integer n is greater than or equal to 0, because remember, it's 0. That's just me trying to save time. Unfortunately, with you using pen and paper, you're going to have to write that out yourself. But I hope that gave you another idea of how we could apply mathematical induction to divisibility tests. Hope to see you in the next example, and see you then.